Hi guys, so today I'm going to be doing the May June 2025 stats paper 5-1. So let's get started. Okay, so the first question. The first question says that masses of bags of rice are normally distributed. So this is a normal distribution question. We don't have the mean, we have the standard deviation, and the probability that the mass of a randomly chosen bag is less than this is this. Okay, so we're just trying to find mu basically. So let's write all the info we know. We know that x is normally distributed with a mean that we don't know, and this is standard deviation, but we have to write variance, so we can just square it. So the probability of x is less than 1.48 is equal to 0.22. So first things first, standardize it. So p of z is less than 1.48 minus the mean all over the standard deviation is equal to 0.22. Since it's z is less than, we can just take phi of this entire value, which is 1.48 minus mean all over this is equal to 0.22. Okay, so the best thing to do right now is to take the phi to the other side, and we'll have like phi inverse. So basically be phi inverse of 0.22 is equal to this entire value. I don't want to keep writing it, but I don't have a choice, so I'll just write it. Okay, so we have phi inverse. So whenever we have phi inverse, what do we have to do? We have to go into the normal distribution table in the MF19. Okay, so we have to go inside these values and look for 0.2. But here's the problem, it starts from 0.5, not 0.2. So what we're gonna do? So the best thing to do right now is negate this entire value. So just put negative, and then we'll do phi inverse of 1 minus 0.22, which is equal to this entire value over here. Let me write it down real quick. So we're just going to ignore like the negative. We're just going to keep it here, right? And we're going to find phi inverse of this, which is 0.78, I think. Yeah, it is 0.78. So we're going to go back into the graph, and we're going to look for 0.78. So this is 6. Okay. 7. Where's, okay, wait, why can't I find it? Okay, this is 7, this is 7, 8. This is like too high, so we're gonna stop over here. So this is 0.7, this is 0.07. Okay, so to get 0.78, we have to add 6, right? And we like go through this place, and 6 is over here. So we have 0.772. So we go back to our paper, and we know that we just keep the minus, and this is 0.772, and this is equal to the same thing, like 1.48 minus mu all over 1.14. So now this is like a really normal equation. You just solve it normally. So this goes to this, and we multiply. So we're gonna get, why does it keep changing to years? We're gonna get minus 0.10808 is equal to this, and we can take mu to the other side, so it'll be this plus this, and we're gonna get 1.588. 3 sig fig, you round it, you get 1.59, and that is your answer for mu. So this is it for the first question. Okay, so the second question starts with perms and coms, because find the number of different arrangements of the A letters in the word kangaroo. The two A's are together, the two O's are not together. So that's the two conditions. So the first thing I'm going to do is how many letters? There are 8 letters, right? And there are, these are A's and these are O's. So without that, we'll have 4 letters. So the first condition is the two A's are together. So I'm going to write the two A's, and I'm going to put them in a box because they're together. Okay? And then the two O's are not together, but before I do that, let's do the other 4 letters, K, N, G, R. So that's 1, 2, 3, 4. Okay, now the O's are not together, so where can we place them? We can place them in between, in these places. So like all these places, we can have an O over here. right? So let's see. So this is 1, 2, 3, 4, 5, 6. So out of these 6 spaces, you can put 2 O's. So that's going to be 6 permutation 2. But the O's are the same, right? So whenever they're the same, we're going to do 2 factorial. Okay. And the next one is the A's. Like, we can swap the A's. So that's 2 factorial. But there's actually no point in doing this because the A's are the same. So we're going to do 2 factorial again. And this is just going to cancel out. So there's no point of writing it there, but I'm just writing it for understanding. And the last thing is all the other letters. How many times can you like swap them? So there's 1, 2, 3, 4, 5. This is considered as 1 because we group them together. So we basically have 5 factorial. So you just like input it into the calculator and you're supposed to get 1800. Okay, so the next question is, if our 8-sided dice has faces labeled this kangaroo, okay, find the probability that fewer than 6 rows are required to obtain an 8. So the hardest thing in the stats paper, I think, is figuring out which topic a question falls under. Like the first one was fairly easy, pros and cons, but this one, you can tell it's probably like binomial distribution or geometric distribution. So you just look at the info they've given you. They have given you obtaining an A and like the letters. So you have like probability of success, right? That's the only thing you have. And you only need that for like geometric distribution. So this is a geometric distribution question because you don't have like the total number of childs and everything. So we know that X is geometric distribution and you have required to obtain an A. So we have 2 A's and they're 8-sided. So obviously that's 2 over 8. That's the probability, which is 1 over 4. Okay, fewer than 6 rows. So that's P of X is less than 6. So whenever we have less than 6, we just like rewrite it. So we have 1 minus P of X is greater than or equal to 6. Because if it's not less than 6, it's 1 minus greater than or equal to 6, right? So that's 1 minus the Q raised to the power how many times you filled. So that's 5 times. And we know that Q is 1 minus 1 over 4. So that's 1 minus 3 over 4 raised to the power 5. And you just put in the calc and you get a fraction, which is 7a1 over 1024. But you can just write it in 3 sig fig, which is going to be 0.763. Okay, last question. Find the probability that the second A is obtained on the 6th roll of the dice. Okay, so we're rolling 6 times. So let's do like 6 dashes. 1, 2, 3, 4, 5, 6. Okay, so like in this first 5 dashes, you're going to get 1 A. And on the 6th roll, you're going to get another A. So out of these 5 parts, you're going to do like there's like 5 different places, but you're gonna get it once, so you can just do 5 combination 1. And then the probability of success is 1 over 2 and the probability of failure is 3 over 4. So we know that you're going to be successful twice because you're going to get 2 A's, and you're going to be unsuccessful 4 times. So this is it. You just do, because you do 5 choose 1, because out of these 5 options you can get A1s, and then you just multiply all of this and you're going to get 405 all over 4096. You can just write it in 3 sig fig and you get 0.0989. So this was it for the second question. Okay, so let's move on to the third question, which is kind of a lot, but it's very easy. So third question. Last Sunday, teams of runners took part in a charity event. So this is time taken in seconds. Okay, and there are 11. Okay, so this is just like the intro. What they want us to do is draw a back-to-back stem and leaf diagram to represent the information with goals on the left hand side. So that's the most important bit. You have to put the goals on the left hand side. So let's draw the stem and leaf. So you like do 2 long lines for like the stem. Yeah, and then we have to put goals on the left hand side, and what was the other team again? Herons. Yeah. Okay, so we can see that it starts from 7 and it ends at 10. So we're just gonna put the stem at 7, 8, 9, 10, and you're gonna quickly write all these numbers. So yeah, it's gonna go like this way because like it's on the left hand side. So we have 7.10 8.9, and then we have 8.2, 8.36, 6, 8, 9.2, 9.7, 9.8, 10.0, 10.4. Okay, so we're done with the left hand side. For the right hand side, here is the trig. They actually did no order for you so that you can see this is 9, and then there's 8. But then if you're in a hurry, you might not see it, even though it's like really clearly there. So the first thing you have to do is rearrange it. Obviously, it's not gonna take that much time, so just do it real quick. So we have 8.1, and then we have what? Let's just rearrange it real quick. So we have 8.3, and then we have 8.5, which is just on top. We have 8.7, 9.2, 9.3, 9.5, 9.7, 9.9, two 9.9s, and the last one is 10.8. So, and then you can do the right hand side. So it starts, there's no 7 though. So there is 1, 3, 5, 7, 2, 3, 5, 7, 9, 9, and 8. Okay, so you think you might be done, but it's 4 marks. So the last mark is for your key, which is very, very important. Like if you do not have a key, you lose marks. So for the key, you just have to explain what it is. So we can just take like the last bit, like 0, 10, and 8. You just have to explain what it means. So this means that this is like 10.0, right? So this means 10.0, you have to add the units, it's in seconds for girls, and 10 point, wait, I did 10.8 for, yeah, I messed up, it's 10.0. You actually cannot be messing up like this. These are like petty mistakes. So this is for girls, and 10.8, do not swap them. That's like the worst thing you can do for Hurons. Okay, so we're done for the tree diagram. Okay, next part. Find the median and interquartile range. This is also very simple for the girls. So they're 11, so this is 1, 2. So like since they're 11, we're gonna go to the sixth one. So 1, 2, 3, 4, 5. This is the sixth value, and they're like 5 on either side. So the median is like literally in the middle because they're 5 here and 5 here. So that's 8.8. So you can just write that down. Median is equal to 8.8. And then they said interquartile range, which is IQR. So for IQR, you have to do Q3 minus Q1. So let's go find them real quick. So we have 5 on this side, 5 on this side. So the middle is obviously the third number and the third number. Remember, we're going like this way. That's like the only place you can mess up. So this is 8.3 and 9.8. So Q3 is 9.8 and Q1, oh, how did that become an O, is 8.3. You subtract to get 1.5. So now you have your median and you have your interquartile range. Okay, now moving on to the last part of this question. It's just a long question, but it's not that challenging. So two other teams. Okay, now there are 2 other teams. And then we have 20 runners from Eagle, 30 runners from Swift. Eagles is X, Swift is Y. It's given that sum of X is this, mean of Y is this, find the mean time. So you cannot do it separately, right? You cannot just find, you have the mean, you can't just find the mean and add it. That's not how it works. So what you have to do is you're finding total mean, right? So mean is actually equal to sum of X plus sum of Y together, all over n1 plus n2. So we do have the sum of X, which is 157, and we also have the number of X, which is 20, right? The number of total equals. But then we have the mean of Y. So we have what? We have sum of Y. No, we have the mean, which is 8.4 is equal to sum of Y all over the total number of runners, which is 30. So sum of Y is equal to, you're going to multiply these two and you're going to get 252. So what you're going to do is you're going to add the 252 over here and the 30 over here. And you're just going to enter into a calc and you get 8.54. and your answer, that's your answer. Okay, and the last part is given that sum of x squared is this, standard deviation, and they give you the standard deviation, and they want you to find the value of y squared. So it's together again. So for these, you just have to remember the formulas. It's even in the MF19. Yeah, so standard deviation is, this is like the formula. Standard deviation is equal to square root of sum of x squared plus sum of y squared all over n1 plus n2, and you're going to subtract it from mean squared. And you already found the mean in the previous question, so it makes life easier. So they gave you the standard deviation is 1 point this, and they give you x squared, sum of x squared, which is 1823. We're trying to find this. You know how many people there is, 20 plus 30, so it's just 50. You just found the mean as 8.53. Do not forget to square it, it's very important. So now we're basically doing change of subject. So we're going to square both sides and get this squared. So the square is gone. Now we're going to add 8.54 squared. And then we're going to multiply everything by 50. And the last thing we're going to do is subtract 1823. And all this is equal to sum of y squared. So you can just directly enter the entire thing into your calculator, and you get your answer as 1918.8. And they said correct to one decimal place, so this is your answer. So yeah, that is it for question 3. It was quite a lot of marks, but it's data rep, so it's like on the easy. Okay, so question 4. Every Saturday, a particular community holds a puzzle event. Last Saturday, 600 competitors took part. So whatever answer you get, you're going to multiply by 600. The time taken to complete the puzzle was normally distributed. Normal distribution question. Okay, so let's write down the basic info that we know, which is x is normally distributed with a mean of 32.4. Standard deviation, so variance of this. Okay. But here's where you notice that they want us to do how many competitors would you expect to have times within 1.2 minutes of the mean time. So this isn't like a typical greater than less than question. It's like an interval question. So let's do like a quick drawing of it. So this is like the mean time, and they said within a 1.2. So to the right we have 1.2, to the left we have 1.2. So this is like 1.2 over here, and since we're going to the left, it's like crossing 0, so this would be like minus 1.2 because mean is 0. Okay, so the best way to do this, I think, is this is x, right? So it's just to do like x minus mean, and this is the interval. So we know that this is 1.2 minus 0, which is 1.2, and minus 1.2 minus 0 is still the same. So now we have the basic. So what we're gonna do is we're gonna standardize it real quick. But you know, when you're standardizing, you just do minus mu all over standard deviation, and this is already in terms of minus mu, so you just divide by standard deviation on both sides, which is 2.5. Okay, so we can continue from here. So when we continue from here, we are at, just calculate it real quick, that's 0.48 is less than, where z is greater than this, and z is less than 0.48. Okay, so this is, these are the same values, so if you know the interval rules, this will be really easy for you, which is 2 phi minus a. 2 phi of a minus 1. Wait, my bad. Let me write it. 2 phi of a minus 1, where a is like the same value. But just in case you don't know, let me do like a quick demo. So they're both a, right? So like it's like the same thing. I'm just drawing it again. So we have a over here and we have minus a over here. So this is like what we're trying to find. Just assume that a is 0.48. They're the same value. So obviously to get it, we have to find the area. We have to find phi of a minus phi of minus a, right? Because this is like minus. Okay, so when you're simplifying, get phi of a minus 1 minus phi of a, not 5 minus a. So that's phi of a minus 1 plus phi of a. You just simplify 2 phi of a minus 1. So that's how we got this. So it just makes life easier if you already know it. So you don't have to do like all these extra lines of workup. And this is 0.48 minus 1. Okay, so we're going to go to the MF19 real quick and get 0.48. So, okay, let's go to the 0.48. So this is not phi inverse, so we just go from here. So this is 0.4, this is a, you come down, this is where they intersect, 0.6844. So we have 2 of 0.6844 minus 1. Just put in the calc, you get 0.3688. Okay, but you might think you're done, but remember the 600 competitors that took part, do not forget about them. So you just multiply by 600 and you get 221.28. Okay, now we're talking about competitors here, right? They're like people. We can't have 0.28 of a person, so I'll just round down and I'll get 221. But in the mark scheme, you can actually round up as well. You can get 222, but both of them are correct. Okay. Next question. In this Saturday's event, 60% of the competitors had a time less than this. 9 competitors took part. Okay, so now we know the total amount of people, so that just narrows this down to, we have like probability of success and everything. That just narrows it down to binomial distribution. So we know that, wait, my bad, X is binomially distributed with a total of 9 people and a success rate of this. Okay, so find the probability that at least 2 fewer than 8 had times less than, that's like the probability, so that's fine. Okay, so we're trying to find P of X is at least 2, so it's like greater than or equal to 2 and fewer than 8. So which numbers do we have? We have, so it has to be 2, 3, 4, 5, 6, 7, because 8 is not part, all of these numbers. Okay, but we have 9 competitors in total. So do you think it'll be easier to just do 1 minus 9, like all the other options, like P of X, this is a big bracket, P of X is equal to 8 plus P of X is equal to 9 plus P of X is equal to 1 on the other side plus P of X is equal to 0. Personally, I think it would be better to do this because over here you're dealing with like 4 different numbers, but over here you have like 6. It's just like a difference of 2, so it doesn't really matter that much. So we can do it either way. So we can just do 1 minus this or this, and it's a lot of work either way, so you just have to do all the working. But initially I just did, at first I didn't even realize that you could do it the other way. I just did it the longer way, so I'll just keep doing that, I guess. So you just have like, the first one was P of X is equal to 2, right? So that's going to be, out of the 9 people, you're going to choose 2. Rate of success, raised to the power 2, times rate of failure, raised to the power 9 minus 2, which is 7. And it's just going to repeat that for every single value, no matter what you do. And for this, you get 0.02123366. Just continue doing that. Whichever way you do it, you have to get 0.9256. Round it 0.926236. Yeah, so this was binomial distribution question. And this one, the part C, it says 80 competitors took part. Okay, they're selected at random. Suitable approximation to find the probability that more than 50 had a time less than this. So we already know the probability for that, by the way, is 0.6 from the previous question. Okay, so you know when they say approximation, you're going to have something in binomial and then you're going to convert it to normal, because we're going from like, okay, let's start. So first, binomial distribution. So we have X is total of 80 people took part and probability of success is this. But we're going to have to move it to N. And for n, mean is np, and variance is npq. So you just multiply 80 times 0.6, you get 48. Multiply the answer by 0.4, you get 19.2. So yeah, we have converted this to a normal, because doing this with binomial distribution will take forever, and then after like mini research and everything, they figure out that you can do it with normal. But here's the problem, it's like slightly off. That's why you have to like do plus or minus 0.5. Okay, so that's the next thing we're gonna do, because this is discrete and this is continuous, so we're gonna have to like make it like plus or minus 0.5. So let's do that part. So we're doing what? Probability of x is greater than 50, right? Okay, so we have 50, but we're doing x is greater than 50, so that's 51. Okay, and then so it'll be like this entire place, right? Like it'll just continue, but then we're gonna like, we can move a bit to this side, right? So this side, so that'll be 50.5. That's basically it, because like this is the entire thing, but like we can move a bit 0.5 to this side, so we like normalize it basically. Okay, so now we're gonna have p of x is greater than 50.5, no longer 50. If you don't do this, it just like does not make your answer correct. This is like very important part of it. So standardize it. Z is greater than 50.5 minus 48 all over. Remember, this is variance. You have to square root it to get standard deviation, 19.2. Okay, so that's P of Z is greater than 0.571. Okay, so since this is greater than, you just do 1 minus phi of 0.571. Why exactly are we doing this? We can just draw out real quick. We have 0, we have 0.571. We're trying to find greater than, so we just do 1 minus less than. So that's what we're doing, 1 minus less than. So we go back to the normal distribution, 0.571. Okay, so we go 0.57, wait, over here, 1. So that's 0.571. So that's 5160. Sorry, 7160. So that's 1 minus 0.7160, and we're gonna get 0.284, and that is your answer in 3 sig fig. Okay, so moving on to question 5. It says, in a group of 20 musicians, 9 guitarists, 6 pianists, 5 drummers, 6 musicians are selected. So once this is selected, you know you're doing combinations. Find the number of different ways they can be selected if there are at least 3 guitarists, most 2 pianists, exactly 1 drummer. So you have to find like how exactly it's gonna be. Okay, so we have guitarists, pianists, and drummers. So let's start with drummers. Exactly 1 drummer. Okay, so drummer is always going to be 1. At most 2 pianists, so let's start with 2 pianists, because that's the most they can have. And there are 6, so that's going to leave us with 3. Okay, now we have 1 drummer again, but at most 2 pianists, so we can have 1 pianist. And that's 2 minus 6, which is 4. Okay, and we have 1 drummer again, but now it's at most 2 pianists. We already have 2, 1, we go down 0. You can have 0 pianists. That means that we have to have 5 guitarists, and guitarist is at least 3, so it has to go up from 3. Pianos is at most 2, so it has to go down from 2. Drummer is exactly 1. So these are all the options that you have. So this is a fairly easy question. I don't know why it's 4 marks, but that's good. You get more marks. Okay, so out of 9 guitarists, so you do 9 choose 3 multiplied by 6 pianists. 6 choose 1, 6 choose 2, 5 choose 1. You do the same, so 9 choose 4 times 6 choose 1 times 5 choose 1. 9 choose 5 times 6 choose 0 times 5 choose 1. You enter them in your calc. For the first one, you get 3600. 6300. For the second one, you get 3780, and the last one you get 630. Okay, so these are all options. So it's either you can get this or this or this. So since it's or, like, it's either this entire thing or this entire thing, we're gonna add all the final answers. So it's 6300 plus 3780 plus 630. You add all of that, you get 10710, and that's your final answer. Okay, so the next part. Three bands will be selected from the original group of 20 musicians. Each band will contain of 3 guitarists, 1 pianist, 1 drummer. No musician can be in more than one band. So this is like the most important line for this question. First band will play in Paris, in France. Second one in Italy. Third one in Spain. So that's why no musicians can be in more than one band, because maybe they're like performing simultaneously, right? And they have to be in like different places. Okay, so let's start with France. So we're gonna choose 3 guitarists. So the original question is still there. We have how many? 9 guitarists, 6 pianists, 5 drummers. Let's write that down. So we have, there's actually 9 guitarists, 6 pianists, 5 drummers. That's like the total number. Okay, so France, 3 guitarists. So out of the 9 guitarists, you choose 3. 1 pianist. Out of the 6 pianists, you choose 1. And 1 drummer. Out of the 5 drummers, you choose 1. Great. Let's move on to the next country. Italy. So notice how it said no musician can be in more than one band. So right now you do not have 9 guitarists anymore. You have 6 guitarists, because you already took away 3. So out of the 6 guitarists, you're going to take 3 more. And also you don't have 6 pianists anymore. You have 5 pianists, because you already took 1. So out of the 5, you're going to choose 1. Same thing for the last thing. You don't have 5 drummers. You have 4 drummers, and you're going to choose 1. Okay, what's the last country? Spain. For Spain, now out of the 9 guitarists, you took 3 guitarists, and then you took another 3 guitarists, 6 guitarists gone. So with the remaining 3, you're going to choose all of them. So for pianists, it'll be 4, choose 1. Drummers, it'll be 3, choose 1. Okay, now you just calculate, just multiply them. You're going to get 2520, 400 for this, and 12 for this. Now, here's the great question. For the previous question, we added them because it was this or this or this, like options. But for these questions, do you think we're going to add them, or we're going to like multiply all these numbers to get the final answer? So here's the thing. This is not an or question. It's not like they'll be performing in France or they'll perform in Italy. They are performing in France and Italy and Spain. So this is like an and situation. And you know that whenever it's and, you have to like multiply, right? Like you're not adding. So that's just the thing that's like the only thing you have to realize for this question. You do 2520 times 400 times 12. You're gonna get a really huge value. You might think it's wrong, but you're actually right. So this is the final answer. Wait, there's one more zero. 1, 2, yeah. This is like a million, bro. That's like a really huge number. Okay, so this is it for question 5. Okay, so finally the last question of the paper. And then you have like an additional page. Okay, so a bag contains 10 marbles, 4 are red, 6 are blue, 4 are selected at random without replacements. Very important to know that it's without replacements. Okay, so random variable x denotes the number of blue marbles selected. So show that. This is a show that question. You can easily do it. The word that you have to keep in mind is selected. So we're going to use combinations to solve this question. So we're trying to find the probability of x is equal to 2. How are we going to do that? With combinations. So what is x exactly? The random variable x denotes the number of blue marbles. So x is the number of blue marbles selected, and we have to choose 2 blue marbles, right? So out of the 6 blue marbles, we're going to choose 2. So x is going to be right. And we're choosing how many in total? 4 marbles in total. So out of the red, we're also going to have 2, because there are 4. We have 2 blue, we have to have 2 red. And then since it's a probability, we need a denominator of the total thing. So out of the 10 marbles, we're choosing 4 marbles. You just enter into the calc real quick. It's a show that question, so you know that if you're wrong, you're wrong. And you get 3/7. Okay, so the second thing is they want us to draw a probability distribution table. And that's easy. So first you have to figure out how many possible options there are for x. X is the number of blue marbles selected from like 4 marbles, right? 4 marbles are selected and it's the number of blue marbles selected. So out of the 4, you can have 0 blue, you can have all red, that is. You can have 1 blue, you can have 2 blue, you can have 3 blue, or you can have all blue. So that's what we're trying to find. And for you have to find the probability. We don't have to find for 2 because we already found it. So let's find it for the rest. Put them in a table, add up all the probabilities, make sure it adds up to 1 to check if you're correct, and you're done. Okay, so P of x is equal to 0, which is going to be x is equal to 0. That means we're choosing all reds. How many reds are there? 4 reds. So we're going to do 4 choose 4 times 6 choose 0. You don't have to bring the 6, choose 0. And out of the total, and you're going to get 1/210. Next is x is equal to 1. So out of the 4 reds, you're going to choose 3. Out of the 6 blues, you're going to choose 1 over the total, and you're going to get 4/35. And then we have to do it for x is equal to 2. We already have it. So 3 is, out of the 4, you choose 1. Out of the 6, you choose 3. All over total. And you're going to get 8/21. And the last one. 4 choose, wait, now we have all blue. So you're going to choose 0 of the red. You're going to choose 4 of the blue. All over the total. You're going to get 1/14. Okay, so now you have all the numbers. Let's continue in the next page. Now we're just going to draw the table. So we have x over here, and we have the probability of x is equal to x. We just have to write that. And then it's 0, 1, 2, 3, 4. And you have to like box it. And just try to draw straight lines with a ruler. I'm just drawing it with my free hand. It's pretty straight. But like do it with a ruler so it looks neater. And you just write your numbers there. So 0 was 1/1, what's it? 120. Why does my 0 look like a 6? And then 1 was 4/35. 2 was 3/7. It was to show that 8/21, 1/14. So this is the probability distribution table. It looks a bit wonky, but like do yours nicer. And yeah, and you can like add up all these values to see if you get 1. If you don't, you know that you messed up somewhere and you just have to redo it. Okay, last question of the paper, and then you're done. So find the probability that at least 2 of the marbles chosen are blue given the conditional probability. You have to remember the conditional probabilities, which is P of B given A is equal to probability of A intersection B all over probability of A. Okay, so let's see what this is. So B given A, what's B? At least 2 marbles are blue. So blue is at least 2, so it's greater than or equal to 2. Given that at least 1 red and at least 1 blue are chosen. So red is greater than or equal to 1 and blue is greater than or equal to 1. So this is essentially what you're doing. So write it out nicely. So you have probability of B is this intersection. Wait, this is A. It doesn't matter. It's just like both of them intersection. And yeah. And then you have all of this over probability of A, which is the second one. There's just probability of at least 1 R and at least 1 blue. Okay, and you know what's going to save you for this question? The graph, the table I just drew. This is literally the only way you can answer it, I think. Like, that's the best way to do it. because it's a follow-up question, just use your answer from the previous question, okay? So they said, let's do the denominator first. At least one and at least one red and at least one blue are chosen. So let's go over here. So we cannot have like no red, and we cannot have, this is no red and this is no blue. So we cannot have that. We have to have at least one blue, two blue, three blue, not all blue, and not all blue and not all red. So these three options over here, those are our options. So we have all this over 4 over 35 plus 3 over 7 plus 8 over 21. Okay, and then the top is this and this, so intersection. Blue is greater than or equal to 2. And then, so we chose these, right? Blue is greater than or equal to 2 is obviously 2, 3, 4. But like we have to find the intersections, which is this and this. So it's just 3 over 7 plus 8 over 21. So we're just gonna put in that calculator real quick. You get 85 over 97, and just write in decimals, you get 876, and that's your answer in 3-sig figure. Okay, so this is the end of the video. I hope you don't have any doubts anymore. Yeah.